Welcome to our comprehensive guide on Java 8 interview questions and answers. In this video, we'll walk you through the most important topics you need to know to ace your next Java interview. Whether you're a seasoned developer or just starting out, understanding Java 8 features is crucial for modern Java development. We'll cover everything from Lambda expressions to the new datetime API, ensuring you have a solid grasp of the concepts interviewers love to ask about. Let's dive in and explore what makes Java 8 such a game changer in the world of programming. One of the standout features introduced in Java 8 is Lambda expressions. Lambdas allow you to write cleaner and more concise code, especially when working with collections and functional interfaces. Instead of creating anonymous inner classes, you can now use a simple syntax to pass behavior as a parameter. This not only reduces boilerplate code, but also makes your programs easier to read and maintain. Understanding how to use Lambda expressions effectively is a key skill for any Java developer, and interviewers often ask candidates to demonstrate their use. Java 8 introduced the concept of functional interfaces, which are interfaces with a single abstract method. These interfaces are the foundation for Lambda expressions and method references. Common examples include Runnable, Callable, and the new built-in interfaces like Predicate, Function, and BiConsumer. Knowing how to identify and implement functional interfaces is essential, as they are frequently used in Java 8 APIs. Interviewers may ask you to create your own functional interface or use one in a practical coding scenario. Java 8 comes with several built-in functional interfaces that simplify common programming tasks. These include Predicate, BiPredicate, Function, BiFunction, Consumer, BiConsumer, Supplier, UnaryOperator, and BinaryOperator. Each serves a specific purpose, such as testing conditions, transforming data, or consuming values. Understanding when and how to use these interfaces can make your code more modular and expressive. Interviewers often expect you to know the differences and use cases for each of these interfaces. Predicate interface represents a boolean-valued function of one argument, making it perfect for filtering and matching operations. BiPredicate extends this concept to two arguments, allowing for more complex conditions. For example, you might use predicate to filter a list of strings or BiPredicate to compare two values. Mastering these interfaces will help you write more flexible and reusable code, which is a valuable skill in any Java interview. Function interface is designed for transforming data, taking one argument and returning a result. BiFunction extends this by accepting two arguments and producing a result. These interfaces are commonly used in mapping and reducing operations, especially with streams. Understanding how to implement and apply function and BiFunction can help you solve a wide range of problems efficiently, which is often tested in interviews. Consumer and BiConsumer interfaces are used for operations that take input but do not return a result. Consumer works with a single argument, while BiConsumer handles two. These are useful for performing actions like printing, logging, or updating values. In interviews, you may be asked to use consumer or BiConsumer in scenarios such as processing collections or handling events. The Supplier interface is unique in that it does not take any arguments but returns a result. It's often used for lazy initialization or generating values on demand. For example, you might use a supplier to provide default values or create objects only when needed. Interviewers may ask you to demonstrate how Supplier can be used to optimize resource usage in your applications. UnaryOperator and BinaryOperator are specializations of function and BiFunction for cases where the input and output types are the same. UnaryOperator works with a single operand, while BinaryOperator works with two. These interfaces are particularly useful for mathematical operations or combining elements in collections. Understanding their use can help you write more generic and reusable code, which is a plus in technical interviews. Method references provide a shorthand way to refer to methods or constructors without invoking them. Java 8 supports four types: reference to a static method, reference to an instance method of a particular object, reference to an instance method of an arbitrary object of a particular type, and reference to a constructor. Method references make your code more readable and concise, and they often appear in stream operations and event handling. A static method reference uses the syntax class name, method name. This allows you to pass a static method as a parameter, making your code more modular. For example, you might use string, value of, or max in stream operations. Interviewers may ask you to refactor code using static method references to demonstrate your understanding of this feature. Instance method references can refer to methods of a specific object or any object of a particular type. The syntax is object, instance method, or class name, instance method. This is especially useful in stream operations, where you want to apply the same method to each element. Understanding the difference between these two forms is important for writing clean and efficient Java code. Constructor references use the syntax class name, new, and allow you to refer to a class constructor. This is particularly useful when creating objects in stream operations or when working with factories. Constructor references make your code more concise and expressive, which is a quality interviewers look for in candidates. Java 8 introduced default methods and interfaces, allowing you to provide method implementations directly in the interface. This feature enables backward compatibility and allows interfaces to evolve without breaking existing code. Default methods are commonly used in API design and are a frequent topic in interviews. Understanding how to use and override default methods is essential for modern Java development. Along with default methods, Java 8 allows static methods and interfaces. These methods belong to the interface itself and can be called without an instance. Static methods are useful for utility or helper functions related to the interface. Interviewers may ask you to explain the difference between static and default methods and interfaces and when to use each. The optional class is a powerful addition to Java 8, designed to handle the presence or absence of values and avoid null pointer exceptions. Optional provides methods like empty, of, and of nullable to create instances and is present, if present, get or else get, and or else throw to retrieve values safely. Mastering optional is crucial for writing robust and error-free code, and it's a favorite topic in interviews. You can create optional objects using optional empty, optional of value, and optional of nullable value. Each method serves a specific purpose. Empty creates an empty optional, of creates one with a non-null value, and of nullable handles both null and non-null values. Understanding these methods helps you manage optional data effectively, which is often tested in interviews. Optional provides several methods for retrieving values safely. Is present checks if a value is present, if present, executes an action if it is, and get retrieves the value if available. Or else get, and or else throw provide alternatives if the value is absent. Using these methods helps you write safer code and avoid common pitfalls like null pointer exceptions. Java 8 introduced a new datetime API to address the shortcomings of previous date and time handling. The new API is immutable, thread-safe, and much easier to use. Key classes include local date, local time, local datetime, zone datetime, period, duration, and temporal adjusters. Understanding how to work with these classes is essential for modern Java development and is often covered in interviews. Local date and local time are core classes in the new datetime API. Local date represents a date without time, while local time represents a time without date. These classes are immutable and provide methods for manipulation and formatting. Interviewers may ask you to demonstrate how to use local date and local time for common date and time operations. Local date time combines date and time, while zone date time adds time zone support. These classes are useful for representing moments in time with or without time zone information. Understanding the difference between local date time and zone date time is important for applications that deal with global users or scheduling. Interviewers may test your knowledge of these classes and their methods. Period and duration are classes for measuring time in the new datetime API. Period is used for date-based values like years, months, and days, while duration is for time-based values like hours, minutes, and seconds. These classes make it easy to calculate differences and intervals, which is a common requirement in many applications. Temporal adjusters are utility classes that help you perform complex date and time calculations, such as finding the next Monday or the last day of the month. They work with the new datetime API and make it easier to manipulate dates in a readable and maintainable way. Interviewers may ask you to use temporal adjusters in practical scenarios. The Stream API is one of the most powerful features in Java 8, enabling functional-style operations on collections. Streams allow you to process data declaratively, using methods like filter, map, reduce, and for each. Understanding how to use streams effectively is essential for writing modern Java code, and interviewers often test your ability to solve problems using the Stream API. The for each method is used to iterate over elements in a collection or stream. It accepts a consumer and performs the specified action for each element. For each is a more concise and expressive alternative to traditional loops, and it's widely used in modern Java code. Interviewers may ask you to demonstrate how to use for each with different types of collections. With Java 8, you can use for each to iterate over maps more efficiently. The map interface provides a for each method that accepts a BiConsumer, allowing you to process key-value pairs directly. This makes your code cleaner and more readable, especially when working with large datasets. Interviewers may ask you to demonstrate this feature in a coding exercise. The for each method can also be used to iterate over lists and sets. By passing a consumer, you can perform actions on each element, such as printing or modifying values. This approach is more concise than traditional loops and leverages the power of functional programming in Java 8. Using for each with streams allows you to process data in a pipeline, applying transformations and actions in a declarative style. This is especially useful for filtering, mapping, and reducing large datasets. Interviewers may ask you to demonstrate how to use for each in a stream pipeline to solve real-world problems. Exception handling in for each requires special attention, as checked exceptions cannot be thrown directly from Lambda expressions. You may need to wrap your logic in try-catch blocks or use custom functional interfaces. Understanding how to handle exceptions in functional code is important for writing robust Java applications. The for each ordered method ensures that actions are performed in the encounter order of the stream, which is important for ordered collections. In contrast, for each may process elements in any order, especially in parallel streams. Knowing when to use for each ordered versus for each can impact the correctness and performance of your code, a detail often explored in interviews. We've covered the most important Java 8 features and interview questions, from Lambda expressions and functional interfaces to the Stream API and DateTime API. Mastering these topics will not only help you succeed in interviews, but also make you a more effective Java developer. Remember to practice coding with these features and understand their real-world applications. Good luck with your Java 8 journey.